Okay, so this is so okay, so this will be our question. Okay, this will be our question. Now I'm going to do this one. Okay, so this is a past paper question. Okay, so you can see that we are given two consolation diagram, one for 16 CAM and one for 16 PSK. Anyone can tell me what is the better one with your general knowledge? What modulation scheme is the better one? 16 CAM or 16 PSK? Okay, so I hope you can answer that one. Okay, so I will continue, otherwise we are running out of time. Okay, so we have two consolation diagram. First, we will see at the 16 CAM consolation diagram. Okay, consolation diagram. Okay, so in consolation diagrams, what are the things we are going to mark? Okay, so here we have two basic function. Okay, for CAM 16 CAM we need two basis function. Okay, if you can remember. Okay, so this is you can get this basis function using Graham-Smith orthogonalization procedure. Okay, I think you have learned this one for your in this course. Okay, in this digital communication course. Okay, this is just like the Fourier series, no? This is just like a Fourier series, but it has some difference. Okay, okay. So you have to find the basis function. Okay, so this basis function are orthonormal, as you can remember, if you can remember. Okay, so here in consolation diagrams we are going to mark our symbols. Okay, so we are going to mark our symbol. Okay, so in 16 CAM you will have 16 symbol. Okay, you will have 16 symbol. You will have 16 symbol like this. Okay, so these are the symbols. Okay, so these are the symbols. Actually, this each symbols is referred to a waveform. Okay, so this symbol is referred to a waveform, sinusoidal wave in radio frequency. Okay, in radio frequency. Okay. Okay, so so we have 16 symbols. That means, in another word, we have 16 waveforms. Okay, 16 waveforms. Okay, so it has different amplitude. Okay, with different amplitude, and with different phase. No, with different phase. The frequency is same. All the waveform frequencies are same. Okay, so we have only one frequency. Frequency is same, and that frequency is in RF range. Okay, RF range. Okay, so so we have 16 waveform for 16 CAM, and each waveform will have different amplitude and a different phase. Okay, so so here we are using 16 waveform. No, 16 waveform. What is that mean? In one waveform with the one signal or one symbol. Okay, so this waveform are also referred as symbols. Okay, symbols. Okay. So you have 16 symbols. Okay, 16 symbols. That means in each symbols you will have 4 bits. Okay, you will have 4 bits. I think this is okay for you. You will have 4 bits, no? So you will have 4 bits. If you have 4 bits, there should be 16 combination. There should be 16 combination. 1, 2, 3, up to 16 combination. So each combination you will need the unique waveform. Okay, you will need the unique waveform. Otherwise, you can't identify this symbol, this bits, 4 bits. Okay, so that the waveform will, the unique waveform will have a different amplitude and different phase. Okay, that is the uniqueness, the amplitude and phase for cam. Okay, okay. So so uh, so these are the general information. Okay, so we have 16 symbols. Okay, actually that is here. Okay, that is why it is called 16 cam. Okay, so here this also we called m, that is number of symbol. Okay, this is number of symbol. Okay, so we have 16 symbols. That means in each symbol we have 4 bits. Okay, for example, if you consider this point, it referred to 4 bits, any bit combination. Okay, any bit combination, it referred to 4 bits. Okay, so we will see the questions. Okay, so what is the first question? How many bits per symbols are conveyed by each of 2 strings? Okay, so all these are 16 array. So M array modulated this scheme, 16 array modulated this scheme. That means 16 symbols are there. That means each symbol will have 4 bits. Okay, okay. So the second point is sketch the optimum decision region for each cancellation. Okay, okay, okay. So this is the 16th cam. Okay, if I tell somewhat with respect to some details with respect to PSK, okay, 16 PSK modulation. Okay, actually you know that BPSK, you have only one basic function. Okay, as I can remember, it is 2TB cos 25 FCT. This is for BPSK. But for QPSK, 16 PSK, 8 PSK, we should have 2 basic function. Okay, so you will have 2 basis function. Okay, so this will be one basis function and this will be another basis function. Okay, okay. So here 16 PSK, that means so here you are not going to change the amplitude and frequency. Amplitude and frequency you are not going to change, so you will have same amplitude. Okay, so you know that in a consolation diagram, okay, consolation diagram, the distance from 0 to somewhere, okay, always referred to the amplitude of the signal. Okay, so this is referred to the amplitude of the signal. You already know this is the amplitude of the signal. Okay, so you can see that here we are not going to, and this angle will refer to the phase of the signal. Okay, phase of the signal. Okay, phase of the signal. So here you have amplitude of the signal and here you have the phase of the signal. Okay, okay. So you can see that in phase shift keying, you are not changing the amplitude. Okay, so you will have same amplitude. Okay, so you will have same amplitude for any point. Okay, for any point you will have same amplitude. Okay, so if you draw a circle, with the amplitude, required amplitude, so all point will be in this circle. Okay, on this circle. Is it clear? If you have any problem, you can ask. Okay, okay. So amplitude is same and phases are different. So here you will have 16 phases actually. So here, so for 16 PSK, you will have 16 phases, 16 different phases. Okay, okay. So you will have 16 waveform. So you will have 16 unique waveform with different phase only. The amplitude and frequency are same. Okay, so you will have 16 phases. Okay, you will have 16 phases. Okay, so so you can mark all the symbol on this circle. Okay, simply. Okay, so here you will have, if this is for 4 PSK, you can get this kind of symbols. Okay, and normally QPSK, you are getting this position, no, for a symbol. Okay, that is easy to easy when we are going to get the decision boundaries. Okay, when we are going to decide the decision boundaries, this position are easy for QPSK. Okay, so this is 16 PSK, so you will have 16 symbols or 16 points. That means this circle should be divided into 16, no? Okay, so this circle should be divided into 16. Okay, so you can simply use this. Here you have divided it to 2, here you have divided it to 4. Then if you divided someone like this, it is for 8. Then each you can divide it again. Okay, then you will have, correct, you will have 16 point, no, 1 2 3 4 5 6. No, no need. I think if you divided it to 8, you will have I will this. Okay, so this is my one basic function and this is my other basis function. Okay, so all the point should be in a circle like this. Okay, so we should have 8 point, no? So here we have 4 points, already 4 points. Okay, so if you have divided this another 2, okay, so we will have another 8 points. Okay, another 8 points, and again you have to divide it to 2. Okay, like this. Okay, so this is not very clear. Okay, I think you can you have the idea. Okay, so I will have 16. So here also we have another symbol. Okay, likewise we will have 16 symbol. Okay, we will have 16 symbol. Okay, 16 point. Okay, each have different face, no? So here you have one face, here you have one face, and here you have another face. So okay, so this is the PSK. Okay, this is the PSK. So now what is the question? So now you are going to ask to draw the decision region, optimum region for 2 cases. Okay, so how we can draw that one? Okay. Actually, you have to define the decision region. Okay, decision region to how to estimate or to check the to check the symbols, the received symbols are correct or not, no? Okay, so for example, if you are using BPSK, okay, so so you will have 2 waveform, okay, with 5 phase shift, okay, with 5 phase shift, okay, and this will be your one point, and this will be your another point. Okay, so as I can remember, it is plus root TB and minus root TB. Okay, okay, now so this is your constellation diagram. Okay, so when you transmit this symbol, some noise will be added. Okay, some noise will be added to this point. Okay, and this point can be shift. Okay, so for example, say now you are sending this root TB. Okay, 5T. Okay, this is your sending signal. Okay, this is your transmitting signal in BPSK. You have learned this. So this is your basis function. Okay, now when you are sending this and when you receive this, okay, when you receive this, okay, so some noise will be added, okay, to this symbol, okay, to this value. Okay, so this noise, okay, so this noise will shift. So this should be your transmitted symbol position, but because of noise, this point will be shift to somewhere. Okay, maybe will be shift to somewhere because of noise. Okay, okay, like this. Okay, so sometime it may be shift to this these symbols onto this symbol also. If the noise power is very high, this point can be shifted to this symbol also. Okay, so so you know that when so you can understand that the received symbol will not be same as the transmitted symbol. Okay, so that is the point. Okay, the received signal or received symbol will not be same. Okay, so it is not equal to the transmitted symbol, because the transmitted symbol will have noise and it is received. Okay, okay, so this received symbol will any point here. Okay, so then you have to decide the received symbol is uh, is uh, is belongs to this symbol plus root TB or minus root TB, no? Okay, for that purpose you have to define decision boundary. Okay, so here you have 0. Okay, here you are two symbol plus root TB and minus root TB. This is for BPSK. Okay, okay. So these are two symbols. Okay, and when your received symbol will be any point here. Okay, so if you are sending plus root TB, it can be any it can be shifted to any point. Okay, due to noise. And this, if you are sending minus root TB, it also can be shifted to any point on this consolation diagram. Okay, due to noise. Okay, then this corresponding the received point, you have to estimate, you have to check whether it is the symbol plus root TB. Let's say this is symbol 1, or it is it a minus root TB. Let's say it is symbol 2. Okay, so received signal, you have to guess this received signal is belong to symbol 1 or symbol 2. Okay, for that purpose you need the region, the decision region. Okay, so normally we normally define a decision region. Okay, actually there is a mathematical way to define the maximum optimal decision region. It is very complex. Okay, it is also based on the probability theory. Okay, but this kind of modulated, okay, so these are somewhat symmetrical. Okay, these are somewhat symmetrical. So this kind of symmetrical modulation scheme, we can just take a decision boundary by looking at the position of two symbols. Okay, so you can see that here you have 0, and here you have one symbol from some distance from 0, and here you have one symbol from distance of 0. Okay, so if you take this as your decision boundary, okay, if the point is in this area, okay, if the received point is this area, okay, in this area, okay, this area, you can say it is a symbol 1. Okay, if the received symbol is in this area, you can say it is a symbol 2. Okay, so how you can define the decision boundary actually? Okay, so you have to look to adjacent symbols. Okay, you have to look to adjacent symbols, and the decision region should be the middle point of these two symbols. Okay, so that is the idea. Okay, did you get that idea? I hope you can understand. Okay, if you have any problem, you can ask me. You can stop and ask me. Okay, okay. So that is the point. What should I want to tell you? Okay, so when you define a decision boundary, okay, for you should be careful. It is for symmetrical, so it seems symmetric. Okay, otherwise the decision boundary will be very complex. You have to calculate it through a mathematical, the set of mathematical equations. Okay, uh, so these are, you can see that these are somewhat symmetrical. Okay, so you can see that these symbols and these symbols are same distance. This symbol and this symbols are in same distance, and this one is identical in same distance. Okay, this one same distance. So this is look like somewhat symmetrical. Okay, Just give me a moment. Okay, I'm sorry. Okay, are you there? Okay, we will start. Okay, so so what here I am explain, when you are find the decision boundary in this kind of uh, in this kind of uh, uh, constellation diagram. Okay, you can simply do it. Okay, by looking at the symbols. Okay, so the requirement is for two adjacent symbols. Okay, you have to get the middle point. Okay, for example, if you consider this one and this one, what is the middle point? And you can see that this one, this one, this one, this one, all these four, 1 2 3 4 5 6 7 8 symbols are there. Okay, so middle point will be this. Okay, okay, so this is one decision boundary. Okay, so if you want to uh, separate this symbol and this symbol, received symbol, you can define this boundary. Okay, so if any symbols is with this section, you can get you can estimate, or you can decide the received symbol is belong to this one. Okay, if the received signals are in this range, this area, okay, you can define, or you can decide the received signal is belong to this symbols. Okay, and what about this one and this one? The same way you have to use the middle point. Okay, so you can get the middle point like this. Okay, so you can see that if you consider this one. Okay, if you consider this one, so you have, so now uh, if received signal in this area, okay, you can direct that it is belong to this symbol. Okay, this is the symbol. Okay, and if the received symbol is in this area, you can decide it is belong to here. Okay, okay, did you get it? Okay, so if you consider this two also, so you have get the middle point. Okay, and here you will have to get the middle point. Okay, so the decision boundaries are, for this case, decision boundaries are okay. So decision boundaries are here. So here, this is one decision boundary, this is one decision boundary, and this is another decision boundary. And you have here one decision boundary, this is another one decision boundary, this is one decision boundary, and this is another. Okay. So if you consider this, if you consider for this symbol, this will be the decision region. Okay, for this symbol. Okay, for this symbol, this will be the decision region. For this symbol, this will be the decision region. For this one, this will be the decision region. And for this one, this will be the decision region. For this one, this will be the decision region. And for this one, this will be the decision region. Okay. Likewise, you can define the decision region for each and every constellation point. Okay. So it is like this. Okay. So you can say that this one, this will be the decision region. Okay, and this one, this will be the decision region. And for this one, this will be the decision region, and this will be the decision region. Okay, so you can see that every point has a decision region. Okay, and also you can see that if you consider these 2 points, the decision region should be like this. Okay, and this point, the decision region should like this. Okay, likewise, you will have, okay, you will have the decision regions like this. Okay, this and this, okay, like this, like this. Okay, so you can draw it, no? So please use a rule and draw. Okay, because you have to careful. So you can see that. I think it is better if you draw this in this way. Okay, if you draw this in this way. Okay, first you have to draw the so first you can draw the point. Okay, so here you have the circle. Okay, okay, and first you can draw the points. So points will be here, 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 4, and again here, here, and here, 8. Okay, and here, 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 here. So 16 point is here. Okay, 16 points are here. So your decision will be, the decision region will be like this. Okay, like this. This, okay, like this, and for this one and this one. Okay, for this one and this one, this one and this one. So you will have this kind of decision region. Okay, so likewise you can draw every decision regions, no? Okay, so I hope you can go, you can do it. Okay, do you have any problem? I think it is clear, but if you have any unclear points, you can ask me. Okay, because my drawings are not very clear. Okay, so if you consider that for this signal symbol, this kind of decision region you will have. This symbol, this kind of decision region you will have. This symbol, this kind of decision region you will have. For this symbol, this kind of decision region you will have. Okay, And for this symbol, this kind of decision region will be have. Okay. So for this signal, this will be the decision region. Okay. Like this. Okay. Did you get it? Okay. So you can draw the optimum decision region. Actually, decision regions are these. Okay. So these are decision boundaries. Okay. And decision region is this. Okay. This area. So this area is the decision region. Okay. So did you get this? If any problem, you can ask. Okay. If you can't understand this, you can ask, because this kind of question will come to your exam. Okay. So please clear if you have any doubts at this point. Okay. Don't postpone it. Okay. Try to clear all the doubts here. Okay. So is that clear? Okay, so we will go to this one. Okay, so we will go to this one, the third one. Okay, so in terms of given cam signal, what is the radius of the 16 PSK constellation in terms of E? Okay, and the both signal constellation have the same average power. Okay, so this is the condition. Okay, so here we have a condition. That means both signal constellation, this signal constellation and now I think you have to mark all the decision region. I think it is not very hard. Okay. For example, this one you have to draw some lines. You can put your you can use your uh, ruler. Okay. You can use your rule. Okay. You can use your ruler. Okay. And you can draw the lines. You have to draw the straight line. Okay. Like this. Okay. So here, like this, you have to draw this kind of straight line. No, it is not hard. Like this. Okay. Like this, you have to draw the straight line only. Okay. Like this. Okay. Then this will be one decision region for this symbol. And this will be another decision region for this symbol. Okay. This will be one decision region. This will be another decision region. This will be another decision region. So on. Okay. So I think it is not hard. Okay. Okay. So we will do this one. Okay. So here said that both signal constellation have the same average power. Okay. So I think this is somewhat important. Okay. Let's go to the constellation diagram again. Okay. So tell me. Okay. Tell me. Uh, one. Okay. So so I will. So we have our 16 cam signal. Okay. So it looks like this. Okay. So this will be our 16 cam signal. No. So you have 16 symbol. Okay. So anyone can tell me. Okay. Anyone can tell me. So here. So this symbol is a sinusoidal signal. This symbol is a sinusoidal signal. Are you agree with that? This is a sinusoidal signal, the physical signal. The real signal should be a sinusoidal signal and it should be an energy signal actually. Okay, are you agree with this? It should be energy signal. Are you agree with this? So this is a sinusoidal signal and energy signal. I think you all agree with me, okay? Because you are sending RF signal. RF signals are sinusoidal in nature, okay? So this should be a sinusoidal signal. Otherwise, propagation is not good, okay? Maybe you can use a square wave, okay, sawtooth wave, okay? But your propagation may be not good, okay? If it is a sinusoidal signal, so that is a nature, okay? Okay, so these are in many practical case, these are sinusoidal waveform. Okay, so this sinusoid in 16 cam, your sinusoidal signal will have different amplitude, and different phase, Okay, okay. So which part is affected to the energy or power of the signal? Amplitude or phase? Amplitude or phase? Can anyone tell me? So maybe for signal and system, you have learned about energy signal and power signals. Okay, so you know that sinusoidal signals are energy and power signals. Okay, so you can find the energy of the signals. Yes, very good. The amplitude will affect to the power or energy of the signal. Okay, and can you remember that? If the amplitude is A, what is the power or energy of the signal? Can you remember? Can you verify this? Can someone tell me? Actually, that is basic signal and system knowledge. Okay? Can anyone tell me? So I think we will get some time to do these questions, okay? Because we can understand the concept, okay? Then other examples we can do quickly, okay? So can you remember the power signals and the energy signals? Can you remember those? So if you can remember, okay, if you can remember, so if you have this kind of signal, a cos theta plus 5, okay, this kind of signal, yes, very good. It is a square, okay. As I can remember, it is a square. I can't remember that a square by 2 or a square, okay. But I also can remember it as a square, okay. So you can, if you can remember that, okay, the energy, you can calculate the energy, okay, by integrate the signal time, okay, the time, okay. So this will be the signal time, the signal duration. What is the signal duration here? The signal duration is the bit duration, no? Okay. So if you have a bit, okay, okay, so so actually not here. So here you are sending 4 bits actually, okay. So here you are sending 4 bits, okay. 4 bits means that is one symbol, okay. So it will be symbol duration, okay. That means 4 TB, okay, symbol duration. The symbol duration is 4 TB in 16 cam, okay, 16 cam. But in BPSK, the symbol duration is equal to the bit duration. Okay, symbol duration is equal to the bit duration, because in each symbol you have 1 bit, but here in one symbol you have 4 bits. Okay, so 4 into the period, the bit duration is equal to the uh, symbol period. Okay, so 4 4-bit duration will be equal to the 1 symbol duration. Okay, this is for CAM. Okay, so if you are using 8 PSK, 3 TB will equal to 1 symbol. If you are using 2 BPSK, 2 PSK, that means BPSK, the 1 TB is equal to 1 duration. Okay, so I think these are clear. Okay, so if you want to know any clarification, you can ask. Okay, if you can remember, or if you can't remember these things, you can ask me. Okay, then I can explain. Okay, so if you integrate this symbol, that is a cos 25 FCT plus 5 like signal within the TB. Okay, you have to get this square. Sorry, you have to get this square, and if you so you have to get the magnitude value. So these are real signals. Okay, these are real signals. I forgot to tell you, all the transmitted signals are real. Okay, because these signals are generating using oscillators. Okay, in the practical circuits. Okay, these signals are generating using oscillators. Okay, so another thing is these all signals are real. Okay, these are real signal because oscillator can generate only real signals. Okay, it can't generate complex signals. Okay, so these are real signals. Okay, so the magnitude is square. Okay, we have to get the square and we have to evaluate it to one symbol. So you will get the energy. Okay, so it is a square. I can't remember, a square by 2 or something. Okay, let's say it is a square. Anyway, it is proportional to a square, definitely. Okay, okay, so the energy, we can say it is the amplitude of the square. Okay, so in constellation diagram, okay, what is this length? What is this length referred? What is this length referred? Tell me in a constellation diagram. I stated it very few minutes ago. Okay, so what is this distance referred to? What of this signal? Okay, I said that this angle will refer to the phase of this sinusoidal signal, and this distance will refer to what? It is referred to amplitude of the signal. Okay, it referred to amplitude of the signal. Correct. Okay, so this distance will refer to the amplitude of the signals. Okay, so you can see that here in this point you have unique amplitude and unique phase. Okay, so that is the uniqueness of this waveform. Okay, this is common for any modulation schemes. Okay, okay, so so this amplitude means it is a voltage level. Okay, so it is a voltage level. Okay, so this is the amplitude. Okay, so if you find this value, if you find this distance, or this the magnitude of this, it is a vector actually. Okay, if you find the magnitude of this line or of this distance, okay, you will get the amplitude. Okay, and if you square the amplitude, what you will get? You will get the energy. You will get the energy of the signal. So so another very important point, using a constellation diagram, we can define, we can find amplitude or energy of the signal. Okay, energy of the signal, energy of the signal, energy of the symbol actually. Okay, energy of the signal. So the signal is corresponding to a symbol. Okay, so sometime you call this energy of the symbol, sometime you can call it energy of the signal. Okay, anything. Okay, so that is the good point. Okay, so tell me, so what do you think about the symbol energy? Okay, so all symbols energy are same or no? All symbol energies are same or not? Can you tell me? For CAM, 16 CAM constellation, in 16 CAM constellation, all symbols energy are equal or not? You can tell it by looking at the graph, okay? Looking at the graph. Energy are not same. Yeah, very good. Why it is not same? Because these amplitudes are different. Okay, this amplitude and this amplitude, this amplitude, this amplitude, these amplitudes are different. Actually, this amplitude and this amplitude will be same. Okay, we will see. I think this is same. Okay, yeah, it should be same. So for this symbol and this symbols, powers are same, energy are same. Okay, but this one, this one, this one, it is not same. Okay, so generally you can say that the symbols of energy are not same, are not same. Okay. So actually that is why we are talking about an average energy. Average energy. What is the average energy? Okay, what is the average energy? So if you can calculate the energy of all points, all these symbols, okay, if you can find the average, find the energy of all these symbols, okay, and if you divided it by number of symbols, okay, so if you can get sum of all symbols energy, okay, energy, and if you can divide it by number of symbols, so it will give you the average energy of the signal. Okay, average energy of the signal. So it is a statical, no, average energy of the symbol. Let's say that it is es, okay, E average es average or something. Okay, so this in this way you can get the average symbol. Okay, so I think you are clear at up to this point. Okay, we are telling many information. I hope you will not get confused. Okay, okay, so these are real signals, energy signals, and power signals, sinusoidal signals. Okay, so the power or energy we can get using the amplitude, and amplitude can be get using the magnitude of this distance. Okay, so that is the summary. Okay, so I hope you get up to this. Okay, so we will continue. Now I am going to find the average energy of the signal. Okay, average energy of this CAM symbol. Okay, because we are asked to find some value. Okay, we are asked to some. Okay, so here we are asked to find the radius of this circle. Okay, so this is a circle. Okay, we are asked to find the circle with respect to the energy. Okay, average energy. Okay, so here it said that average energy are same. Okay, so you can see that for this one also the distance between these 2 points, that is the radius, and that the radius is directly related with the power or energy of these symbols if you are consider PSK. Okay, okay, so if you can find the average power or average energy for this symbol, okay, for these symbols, then you can find the radius, no, because these average symbols are average energy is the same here. Okay, so both cancellation point average energies are same, should be same. Okay, so I am going to find the average energy here, and I am going to get a relationship between the radius and average point. Okay, you can see that it is very clear. We can get that relationship, no, because it is already there. We know that this radius is directly related with the energy of the symbol. Okay, related with the amplitude and related with the energy of the signal. Are you clear? Okay, don't confuse. Okay. Okay, so now I am going to find the average energy of this symbols. Okay. Before that, I want to verify. Okay, I want to verify what is the distance of these symbols. What is this amplitude? Okay, what is this amplitude? To find the amplitude, actually, if we can get this value and this value, you can get it. Okay, so you can see that. So these symbols, okay, so this symbol, if you consider this symbol, okay, so the distance from here to here are same. Okay, so if this distance is d and this distance is d, okay, so this distance will be 2d, and also this distance also will be 2d. Okay, okay, okay. So I will write it here again. Okay, I hope you're clear with this. Okay, so I'm I'm getting this kind of four symbols. Okay, okay. So what do you know? So these symbols, the distance between these symbols and distance between these symbols and distance between these symbols are same. Okay, let's say this is 2d and this is 2d. Okay, so what is the distance here from here to here? It will be 1d, no? So it is 1. Okay, it is 1. And what is the distance from here to here? It is 1 plus 2, so it will be 3. Correct? So it will be 3. Correct? Okay, so and if you consider another 2 point, okay, in vertical direction, okay, and you can see that this will be 1 and this will be 3. Correct? Are you okay with that? I use my general knowledge. Okay, I use my general knowledge of Cartesian coordinate. Okay, so here you have like this. Okay, and this is 1 and this will be 3, and here also you will have 1 and this will be 3, and here you have 1 and here you have 3, here you have 1, here you have 3. So your consolation point will be here, one point will be here. Okay, another point will be here. Okay, other point will be here, other one point will be here. You can see that it is 1 and 3. Okay, correct. So all symbols are, okay, all symbols are somewhat like 1 and 3, 3, 1, 1, 1, 3, 3. This case in this form. Okay, and it can be plus or minus. Correct? Yeah. How to get 1 and 3? It is very simple. Okay, I will explain it again. Okay, so if you consider actually it is given, okay, but I am telling you it is how this how this general, so this is a general knowledge. Okay, so here we have the consolation diagram. In consolation diagram we have 8 points. Okay, sorry, 16 points, because this is 16 can. Okay, we have 16 points. Okay, this is 1 2 1 2. Here also we have 4. Here also we have 4. Okay, 16 points. Okay, so if you consider the distance between these two signals, it is, and distance between these two signals are same. So if I consider this is 2d and this is 2d, okay, so this will be same, no? I use 2d here. Okay, I'm not going, I didn't get d. Okay, because if I get d, I have to use fractional numbers here. Okay, so I don't like to use fractional number here. That is why I get this as 2d. This is just scaling. Okay, I am used for this for a time scaling. Okay, so that is why I get 2d. Okay, so you know that from here to here the distance will be d, and from here to here the distance will be 3d. Okay, but I just put the what is called the ratio only, not ratio. Anupati. Okay. I can't remember the word. Okay, maybe ratio. Okay. So I get only the ratio Anupati. Okay. So here it is 1D. I get 1. Okay. And here it is 3D. I get 3. Okay. So it is, you know, that the ratio is 1D to 3D. Okay. So I get only this value 1 to 3. Okay. So this will be 1. This will be 3. Correct. That is for any constellation, any 8 cam. Okay, any 8 cam. So it will look like this. Okay, so I think you can get, if you have this idea, you can find the what is called. So can anyone tell me what is the word for Anupati? Anupati? Ratio, no? Is it correct? Not remember. Okay. Okay. So yeah, maybe it is ratio. So you know that for any cam constellation, you can get the ratio. Okay, so the requirement is the distance between two symbol should be same. Okay, distance between two adjacent symbol should be same. Okay, then you can get the ratio of this distance. Okay, so it is 1 to 3. Okay, and here also, if you get this distance, this will be 1D and this will be 3D, so it will be 1 to 3. Okay, and here also 1 to 3, and here also 1 to 3. So this will be minus side, this will be minus side, these are plus side. 1 to 3, 1 to 3. So you can get the idea about this position. Okay, like this. Okay, is that clear? I just use my general Cartesian knowledge. Okay, the requirement is, we know that the the the, the value between two adjacent points should be equal. Okay, so if you use the, yeah, you clear, no? Okay, okay, so we will proceed. Okay, so now we are given a clue actually here. So what is it here? We are given a clue. The single points of 16 gamma plus n root t plus or minus n root t. Okay, that is the clue actually. Okay, actually, if you so for this question, you no need to go through like that. Okay, but it is a general phrase. That is why I tell you. Okay, okay. So you can see that any symbol, if you consider any symbol, okay, if any symbol, it is in this form, plus or minus n root t, plus or minus n root t, plus or minus n root t. So this n should be 1 or 3. This 1 or 3. It is same, no? Here also we have 1 or 3. Here 1, if you consider this 1 point, this point is 3, 1. Okay, the position of this card in this is a Cartesian coordinate. Okay, it is 3, 1. So if you consider this point, it is 3, 3. Okay, if you consider this point, it is minus 1, 3. Okay, so it will be plus or minus 1 or 3, plus or minus 1 or 3. Okay, so these are the combination of this coordinate. Okay, so it is given here. Okay, it is given here. It is plus or minus n root t plus or minus n root t. So you can uh, determine this point. Okay, this point is 1 root t. This point is 3 root t. I use my diagram. Okay, so you can very simply determine that. Okay, this point is 1 root t and this point is 3 root t. This point is minus 1 root t. Okay, root t. This point is minus 3 root t. And this point is 1 root t. Okay, this point is 1 root t. This point is 3 root t. Okay, and this point is minus 1 root t. This point is minus 3 root t. These are the coordinates. Okay, now you can find any position. You can find the position of any symbol. Okay, that means you can find the distance. No, using this coordinate, you can find the distance. Correct? Okay. So we will try to find. Okay, are you clear up to this? If you have any problem, please let me know. Okay. Understand this question, then we can do other things also very simply. Okay, I hope. I think we have this kind of question. Okay. Okay. So are you clear with that? Okay. So I will draw the constellation diagram again here. Okay. Okay. So our constellation diagram will look like this. Okay. Okay. So we have coordinates. So this will be root e. This will be 3 root e. This will be minus root t. This will be minus 3 root t. This will be root e. This will be 3 root e. And this will be minus 1 root t. This will be minus 3 root t. Okay. So the points will be like this. Every points will be like this. Okay. So here we have 1 point. Root t. Okay. Here we have 1 point. Root 2 root t, 3 root t, 3 root t. Okay. And here we have another point. Root t, 3 root t. Here we have another point. 3 root e, root e. Okay. So we have 4 points. Okay. In the same manner, you will have 4 here. Okay. And you have 4 here. Okay. And 4 here. Now I want to find the average energy. Okay. Average symbol of energy. Okay. So I will write this. This is one symbol. Okay, this is the second symbol. This is the third symbol, and this is the fourth symbol. Okay, and this will be 5, 6, 7, 8, 9, 10, 11, 12. And here we have 4 symbols. 13, 14, 15, 16. We have 16 symbols. Okay, so you can see that these symbols. Okay, so if you consider these symbols, this distance and this distance and this distance and this distance, these distance are same, no? Because here 1 root t root t. What is this distance actually? This distance will be root e square plus root e square root. Okay, so that is so using the Pythagoras theorem. Okay, so here you have root t, here you have root t, then I get the square of this two distance. Okay, so I have root e square plus root e square, and I get the square root. So this distance, that is distance, and this distance and this distance and this distance are same. Okay, so you can see that the average of the amplitude of the signal and this signals are same. So what about the power and energy? Energy are also same. Okay. Okay. So I get the energy. So let's take that this value is S4. Okay. So so I take this value as magnitude of X4. Okay. Don't confuse. Okay. So this is S4. That means my what is this? My symbol. Okay. And the magnitude of this value I get as magnitude of S4. Okay. Magnitude of S4. Okay. And if I get the square of magnitude of S4, what is this? The energy of this symbol. Are you clear? Okay. So you have such 4 symbols. Okay. So energy of these 4 symbols will be 4 S4 square. Are you clear with this? This S4, I get this I get this value as S4. Okay. Okay. So the magnitude of S4, I get this length as magnitude of S4. So this length is magnitude of S4. Okay, S4 magnitude. Okay, and that is the length, the distance of from here to here. Okay, that is the amplitude of the signal. And if I want to get the energy, I should get the square of the amplitude. Okay, so this will be the amplitude. The magnitude of S4 is the amplitude, and I get the square. Okay, so that is the energy of these symbols. Okay, then I have four symbols, four such symbols. So I multiplied it by 4. Okay, so this terms is equal to this, the energy of this one, this one, this one, and this one. Correct? Okay, energy of this symbol, this symbol, this symbol, this symbol. It is 4s4 square. Correct? Okay. In the same manner, I consider this S4. Okay. So I have this one, S1. Okay. So I, in the same manner, I have like this. Okay. I have like this. Okay. So I get, so there is a distance, no, from here to here. So I get distance as S1 magnitude. Okay, so that is the amplitude of the signal. Okay, and I get the square of that signal, so that is the energy of this signal. So this will be the energy of this symbol 1. Okay, and if you can see that this distance and this distance and this distance and this distance, those are also same. Okay, so I get it. So all four energy I can get as, okay, I can get as 4 magnitude is 2 square. Correct? In the same manner, you can see that if you consider this one, this point, this point, this point, and this point have the same magnitude. Okay, so you will have the same power. Okay, so if you get 4 is, that is 3, no, 3 is square. So that is the whole power for these symbols. Okay, and if you get, if you consider this one, okay, so you can see that this one, this one, this one, this one has the same magnitude. Here, 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 same magnitude. Okay, so if you get the magnitude square, okay, if you get the square of the magnitude, that is energy, okay, energy of one symbol, and if you divided it by 4, so that is the energy of this 4 symbol. Okay, so this is the energy for all 4 signal, all 16 symbol. No, this is the energy of for all total energy. Okay, so this is the total energy of all 16 symbol. Okay, so what is the average energy? To find the average energy, okay, average symbol energy, symbol average, I have to divide this by 16, no, because I have 16 point. Okay, so I divided this by 16, so all these 4 cancel out, then I will have, so here, so I think this is S1, no? Okay, so this will be S1. Okay, and this is S2. Okay, so this will be S2 and S3. Okay, I have, so I don't think you get confused. Okay, you have the idea. Okay, so this is the all symbols. Okay, so you can see that if I add the energy of one symbol, okay, so energy of this symbol plus energy of this symbol, that is S2 square, plus energy of this symbol, that is S3 square, plus energy of this symbol, that is S4 square. Okay, and if I divided it by 4, I will get the average energy. So can you find this value? Can you find this value? So very easily we can find, no? Okay. So can anyone tell me what is the average symbol energy? Try to find, try to get the value for this. Try to calculate. try to get the value for this root in root E, because we have all coordinates. Okay, for example, for this symbol, that is so let's say that S4, this symbol. Okay, so this is S4. Okay, so if I get S4 symbol, okay, so the magnitude square, so S4, the magnitude of square will be, okay, we will see. Okay, okay. I don't think you get, I don't think you will get, okay, let's see. Okay, I'm not sure about that, the point value. Okay, the decimal value. I think it will be a round value. Okay, anyway, let's see. Okay, so if you consider this point, okay, S4, so what is the magnitude of this line? That is root square E, root square E, root square E, root square E, no? Pythagoras theorem. Okay, so you will have root square 3, root square 3. Okay. We no need to get the root square root, because we get the square. Okay, if you want to find the S4 magnitude of S4, then you have to get the square root, but you have to find the magnitude square of S4. So we no need to take the square root. Yeah, I think it is 10e. It should be 10e. Okay, we check. Okay, okay. So so we have S4 square. You have e square 2e. Okay, and what is this S1? Okay, what is S1 square? So that is 3 root t, 1 root t. So 3 square root e square, 1 square. So you have 10e, no? That is 10e for this symbol. 3 square 9, 1 square 1, 9 plus 1, you have 10. So it will have 10e. Okay. So for this one, okay, S2 square, you will have root 3e square plus 3 root e square. That means 9, 9, you will have 18, no? 18e. Okay, so this is S2 square for this symbol. This is root 3e, and this point is also root 3e. This point is root 3e, this distance is root 3e, and this distance is root e, root 3e. Okay, sorry, this distance is 3 root e, and this distance also 3 root e. Okay, so you have 18e. Okay, and if you consider this S3 square, okay, so it is root e square, that is e, plus this point, this distance. That means 3 root e square, that means 9e. So you will have 10e. Okay, see, this one and this one energies are same. Okay, 10e, 10e. Okay, so what will be the average energy? Okay, so average energy, okay, so in ES average will be 2E plus 10E plus 18E plus 10E. Okay, so here you have 20, 40, and it should be divided by 4, no? Okay, so you will have average energy symbol as 10E, correct? So this is the average of the symbol, average energy of a symbol. Okay, so this will be average energy of a symbol. Average energy of a signal, energy of a symbol. Okay, are you clear? Do you have any problem? Then you can, if you have any issue, you can please clear it here. Okay, don't postpone it. Okay, try to get it clear at this point. Okay, don't take much time for that time. Okay, so are you clear? This is the average energy of a symbol. Okay, so that is for CAN. Okay, now what is the condition? Now we have PSK consolation also. we have a PSK consolation also like this. Okay. Okay. Now you can see that. Okay. Now very important thing. Okay. You can see that the different symbol have different energy in CAM. No. So you will have different symbol and you will have different value, different energy. In CAM, different symbol have different symbol have different energy, different energy, different energy, because this amplitude is. So what about PSK? So here you have 8 symbols. Okay, you have 8 symbols like this. Okay, you have 8 symbols like this. Okay, like this you have 8 symbols. So what about this? The symbol, the energy of the symbols are same or not? Please tell me. Energy of the symbols are same or not in PSK? Yes, it is same. Very good. Why it is same? Actually, all these symbols are in same distance. Okay, all these symbols are in same distance. That means all symbols have same amplitude. All signals has same amplitude. Yes, very good. Okay, so all symbols have same amplitude. That means the symbols has equal energy. Okay, so if this symbol has es energy, okay, this symbol will all have es, this symbol will also have es, these symbols also have es. Likewise, all 16 symbols have es energy. Okay, so what is the total energy? Total energy will be 16 es. Okay, and if you divided it by number of symbol, again you will get ps. Okay, so this is the average energy of a symbol, and it is equal to energy of a symbol because all are same. So this will be symbol energy of psk. Okay, average symbol energy for psk is equal to the symbol energy. Okay, but average symbol energy of cam will equal to, okay, 10e. Okay, so this e is some kind of energy. Okay, now what is say? Now what is what they are saying? Okay, this average symbols, this average power, this average symbol power, and this average symbol power are same. Okay, so what does it mean? The average power or energy, okay, power or energy of cam is equal to average power or energy of psk. No, 16 cam is equal to 16 psk. So this is the given condition. Okay, so this is not always true. Okay, because you are designing a system like this. This is not be a requirement for cam and psk. Okay, there is no any point. The 16 cam, the energy of the 16 cam should have the same average energy. That is not must. Okay, you can understand it because here you can find any amplitude value that is based on root tb, because the basic functions are root tb cos 25 fct and root tb sine 25 fct, as I can remember. Okay, I'm not sure. Okay, not root tb, ts, as I can remember. Okay, so it is based on the amplitude and the symbol duration. Okay, yeah, we have to divide it by 16 because the third, yeah. Yeah, yeah. So that is why I explain. That is what I explain. Okay, here you can see that Very good. If you have any unclear point, please please remove them from here. Okay. So again, I will explain. Okay. So here you have 16 point. Okay. Here you have 16 point. Okay. Like this, you have 16 point. Okay. You have 16 point. Okay. Let's say this point is S1. This point is S1, this point is S2, this point is S3, this point is S4. And I get the magnitude of S1, this distance, okay? So that is the magnitude of S1, okay? Now you can see that magnitude of this symbol and magnitude of this symbol, magnitude of this symbol, magnitude of this symbols are same, okay? So there are 4 symbols which have same energy. So you have 4 S1 square. So that is energy of this 4 symbol. Okay. In the same manner, if you get this symbol, okay. So this symbol is okay. Okay, let me explain. Okay. Okay. So this is 4S1 square. Okay. So if you consider this point, this symbol S2, so you can see that this symbol distance, this one same. You can see it. Okay. If you go a line from here to here, here to here, and here to here, those are same. Okay. So you will have same energy for this 4 symbol. Okay. So you can write 4S2 square. Okay. In the same manner, if you consider this symbol, this symbol, this symbol, this symbol, and this symbol are same. So you have 4S3 square. In the same manner, this one equal. So you will have 4S3 square. Okay. And here we have 16 symbols, 16 energy. So we have to divide it by 16. Okay. So this 4 cancel and we have 4. Okay. So you can see that these 4 are identical here and here and here. So if you find the symbol energy of this 3 point and it is divided by 4, you will get the average energy. Okay. Okay. Thank you. The other question is how to equal of average energy of CAM 10 is. Yeah. That is what I explained. We can't equal it. Okay. We can't equal it, and we no need to equal it. Okay. Because CAM is another modulation scheme. PSK is another modulation schemes. Those energies are based on the voltage values and the bit duration. Okay, voltage values and the bit duration. The energies are depend on those 2 parameters. Okay, so there is no any point to equal CAM energy signal with the PSK energy signal. There is no point in a practical system. But in your question, it is given here. So the both signal constellation have the same average power. Okay. So I equal, actually here it is given. Okay. So this is the condition to find the radius of this circle through E. Okay. So is that clear? So in this question, I equal it. Okay. Because it is given. Okay. Okay. You are clear, no? Okay. So we will move. Okay. Okay. So now you can see that for PSK, every symbols has same energy. Okay, every symbol has same energy. So if you get the average symbol power of QPSK, sorry, PSK, 16 PSK signal, okay, you will have the average signal symbol energy is equal to the symbol energy. Okay, because all are same. Here 16 is divided by 16. again you will get ES. So that is the average power, average energy. Okay. So average energy is equal to the energy of a symbol, because all have the same energy. Okay. Now what is the thing? You have to equal the average energy of CAM signal. What is the average signal energy of CAM signal? CAM constellation, that is 10E. Okay. Now the average signal of this constellation is also 10E. Okay. So how to find the average symbol? Average symbol power. 10E is equal to 16 of each symbol energy divided by 16. So you will have energy symbol, the energy of the symbol. Okay. So energy of the symbol should be equal to 10E. Okay. So if you consider this point, energy of this point is equal to 10E. Okay. So what is this value? Okay. What is this value? If you square this value, if this is R, if you square this R, you will get the energy of this symbol, energy of symbol ES. Now what is the energy of symbol? That is 10E. So what is R? Square root of 10E, no? Okay, square root of 10E. This is the R. Okay, did you get this? Okay, so if you have any problem, you can ask now. Okay, you get it, no? So I think others, what about others? Anyone have any problem? If you have any problem, please ask and ask me. Okay. 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 So I will tell you the summary what I am doing here. Okay. Again, because sometime if you maybe you do not feedback, but still you can't understand. Okay. So I have experienced it. So I will tell you the summary again. Okay. So okay. So you can see that. Okay. So if we get this distance, so if I get the symbol S1, S2, S3, S4, okay. So the distance from 0 to this symbol, I get as S1 magnitude, okay. And this symbol is S2 magnitude, and this symbol S2 magnitude, okay. And for this symbol S3, okay, S3, it is, this is S2 and this is S3 magnitude and S4 magnitude. Okay. I think you are okay. So I get this one S1 and this S2, S3, S4. Okay, you can I just put some value, okay, to name these symbols. Okay. So the distance from here to here I get as, so this value, this distance, this length, okay, I get as S1 magnitude. Okay. So this length I get as S2 magnitude, and this length I get as S3 magnitude, and this length I get as S4 magnitude. Okay. So what is this length refer? That is the amplitude. Okay. So if you want to find the energy, you have to get the square of amplitude. So I get the square of this amplitude. Okay. So this will be my symbol energy. So this is the symbol 1 energy, and this is the symbol 2 energy, this is the symbol 3 energy, and this is the symbol 4 energy. Okay. And you can see that this symbol, this symbol, this symbol, this symbol, this symbol have same value. Okay. So all these all this value I can just multiply it by 4, then I can find all these four symbols. Okay, likewise this one and this one, this one same. So here I get 4. Okay, likewise this one, this one, this one same. So I get 4 here. Likewise this one, this one, this one same. So I get 4 here. So if I add this 4 energy, so I will get the all the energy. Okay, to find the average energy. Okay, to find the average energy. Okay, I just divided this by 16. Then I get the energy of this symbol, energy of this symbol plus energy of this symbol, energy of this symbols, all energy divided by 4. Okay, so this is square. Okay, so this one be S1, this one be S2, this will be S3, this will be S4. Okay, so likewise I find the average energy. Okay, average energy of a symbol, average energy of a symbol. Now it is said that the average energy of this consolation diagram is also same. Okay, so here I get 10E average energy. Okay, so this is the average energy, average symbol energy. SA. So this is CAM 10E. Okay, now for this one also average energy should be 10E. Average energy should be 10E. Okay, so you know that over here in PSK all these symbols have same energy. So this have one energy, this also will have a same energy, this also will have a same energy. Okay, so if I find the average symbol energy, it will be ES, energy of one symbol. Okay, energy of some symbol. So the average energy should be 10E. That means energy of one symbol should be 10E as given here. As given here. Okay, so this QPSK energy of energy of a symbol of this PSK, not QPSK, 16 PSK consolation is equal to 10E. Correct? Okay, so now we have to find the radius. Okay, we have to find the radius in terms of E. Okay, now this radius is, if this radius is r equal to, okay, r square. The radius is this radius is proportional to the amplitude, proportional or equal to the amplitude. Okay, so energy is amplitude square. So you have to get the r square to find the energy. So r square is equal to ES. The ES should be 10E. So r square is 10E. So you have r root 10E. Correct? Okay. Now, okay. Now we are so are you clear with this? Are you all clear with this? Okay, so if you have any problem, you can ask me. Okay, so until I will move to this section also. Okay, so what is asked? What is calculate the minimum distance between signal points? Okay, so I think you can directly calculate it for a CAM signal. So what is the minimum distance between two signal points of CAM? Please tell me someone. Okay, it is hard to find here somewhat. Okay, but for a CAM you can find it very easy. So you have a CAM consolation. Okay, you have some value like this. Okay, 16 value, 16 symbols. Okay, okay, now you are asked to find the distance between two symbols. What is the distance? Minimum distance means, so you are asked to find the minimum distance. Okay, that means the distance between two adjacent symbols. Okay, what is this distance? So this is 1 root t, this is 3 root t. So what is the distance? Please tell me someone. What is this d? Here 1 to 3 we get 1 to 3 ratio. Yes, very good. That is 2 root t, correct? That is 2 root t, because this distance, so if you consider this one and this one, this distance will be root 3e. Okay, so this distance will be root 3e. Okay, and this distance will be root t. Okay, and to find this distance, you have to substitute, you have to subtract this distance, no? So from root 3e, if you subtract root e, you will get 2 root t. Okay, so that is the distance, minimum distance between 2 points. That is 2 root. Okay. Now can you find? Actually, here also you can find it is what is called this related with the trigonometric, no, not trigonometric, geometry. Okay. Okay, so now you have find. Okay, so now you have find minimum distance of minimum distance of 2 point of a camp constellation, that is 2 root t. Okay, so this is okay, no? Now you have to find the minimum distance between QPSK. Okay, so here you have sorry, not QPSK, OPSK, 16 PSK. So you will have this kind of 16 consolation point. Okay, so you have 16 consolation point. Now you are asked to find the distance between these two. Okay, so you can see that this is in a circle. Okay, so this is in a circle. This is in a circle. Okay, this is in a circle, and you are asked to find the distance. That means this distance. Okay, so how you find this? Okay, so you know that. So you can see that here, if you get this value, okay, so this is 5 by 2, so this will be 5 by 4, and this will be 5 by 4. Okay, so this, if you get this one 5 by 4, and if you get this point, it will be 5 by 8. Okay, so because you just divide this circle into 16 portion. Okay, so this 16 portion. Okay, so this will be 5 by 8, correct? Because the total angle is 2, 5, and you divide that 2, 5 into 16. Okay, so you will have 5 by 8. Okay, 5 by 8 for one angle between these two adjacent points. Okay, that is 5 by 8. Okay, now how to find this distance? Okay, how to find this distance? Okay, so actually that is related with the what is called that I can't remember the geometry. Okay, so if you get these 2 points on a circle, if you get like this, okay, if you get the if you divide this, if you draw a line perpendicular to this section, this line, okay, this one and this one will be same, this length and this length will be same, because you can I can't remember anga sama dharma again trikona. Okay, so you can find it, this distance will be same, and this is common, and this angle and this angles are same. Okay, so these two what is called triangle are identical. Okay, so this section and this section will be same. Okay, It is called, if you can remember, Akopa. No? Pade Kone Pade. I can't remember. Okay. Okay. So, so likewise, the point is you can say that this one and this one same. Okay. And what so you know that this angles are also identical. Okay. So this angle and this angle will be same. Okay. Okay. So if you consider this point and this point here, okay, so this two angle will be 5 by 8. No, this total angle will be 5 by 8. Okay. And what is the half of this angle? Okay, it will be 5 by 60. Okay, it will be 5 by 60. Okay, so this is the radius. No, this is the radius. This is the radius. And what is that radius? Actually, that is the root of the energy symbol. Okay, if you have this symbol, okay, if you have the energy of a symbol ES, okay, that is the root of the energy. Okay, that is the root of the energy. Okay, so this distance will be root of energy, that is the radius. Okay. Okay, so if I find this distance, what is that? It is root E sine 5 by 16 plus root E. So this is the symbol power. Okay, symbol energy, root E sine 5 by 16, correct? 5 by 16. So the distance minimum of PSK of 16 PSK, we will have root ES sine 5 by 16. Okay. Actually, you can see that if you get 8 PSK, so this one section will be 5 by 6, 5 by 4, because 2 5 angle you are going to divided by 8. Okay, so you will have 5 by 4. Okay, so this will be 5 by 4 in a case of 8 PSK. And if you get the half of value, it will be 5 by 8 again. Okay, 5 by 8 again. Okay, so it will be root T sine 5 by 8. Likewise, in QPSK, you will get root TB sine 5 by 4. Okay, actually, this will be the number of sample, number of not sample, sorry, number of symbol n. Okay, so this is the general. So this is the general general distance between two adjacent point in PSK. Okay, for MRE PSK, we can set that the minimum distance between two adjacent point is so this should be 2 root T, because here root ES plus root ES, so you will get 2 root ES sine 5 by m. Are you clear with this? So this is a common value actually. Maybe you have learned this in your theoretical class. Okay, because this is very important, this minimum distance. Actually, the performance is depend on the minimum distance. Okay, so I clear this. Actually, this is nothing but it is just a trigonometric, no? Yeah, maybe. Okay, it is just a case of trigonometric. Okay, are you clear? I think you better try this at your home as exercise. Okay, so you can prove this. Okay, so try to prove this. Okay, for any PSK MRE PSK value. Okay, MRE PSK value. Okay, so distance between two adjacent point, distance of two adjacent point will be 2 root ES. ES means energy, symbol energy, or the radius. or the radius. Okay, the root symbol energy means the radius. Okay, radius sine pi by m. Okay, so this is a general expression. Okay, that is valid for any PSK modulation scheme. Okay, okay, so in this case it will be root es. Okay, so in this case it will be root es sine 5 by 16. Okay, 5 by 16. Okay, and you know this root es, the radius already, you know what is that, root 10e. Okay, so you will have 2 10 root 10e sine 5 by 16. Okay, so can you find this value? What is the value here? Can someone find the value? Please tell me. So I think the value should be, okay. Okay. So can anyone tell me, please calculate it quickly? Using a calculator or using a MATLAB, you can calculate it very quickly. Please tell me the answer. So you can see that the distance between these two point will be 2 root t. Okay, this will be 2 root t. So this is the distance, minimum distance of CAM, minimum distance between adjacent point. Okay, minimum distance of two consolation point, that is 2 root t. Okay, and for this one you will get, okay, maybe 0.0216. So I'm not sure, because it should be, yeah, maybe it should be less than. Okay, it should be less than, yeah. So so here the minimum between these 2 point, okay, minimum distance between these 2 point, in PSK, in any memory PSK, you will have 2 root es. Okay, 2 root es means here it is 10e. Okay, divided by sine 5 by m. So m is here 16. Okay, so so let's say that this is R1 and this is R2. Okay, definitely R2 should be less than R1. Okay, so the distance, okay, so this is the distance. Okay, let's say it is D1. So let's say the distance here is D1. It is for CAM. Okay, and distance for this, let's say it is D2. Okay, so D1 should be greater than D2. Okay, definitely this should be like this. Okay, how I say like this? Because we know that PSK performance are less than the CAM performance. Okay, the bit error rate performance of PSK, if we consider the bit error rate of, I know it by practically. Okay, in practically, because I just tell you. Okay, so if you have a tower like this, okay, if you have a tower like this, okay, so let's say that this is a 4G LTE site, 4G LTE site. Okay, so practically we will have normally if we get around, so let's say so if we get around 32 dBm SNR dB value is 22, it is very good value. Okay, actually this is the maximum value we can get according to my experience. Okay, 32, 33 likewise. Okay, and I think 20 to 25 SNR dBm, okay, SNR value will be very good. Okay, will be very good. Okay, then maybe 16 to 20. Okay, then below 60, below 60. Okay, so if you have good SNR in this range, normally, okay, your LT will work on CAM modulation scheme. Okay, on CAM modulation scheme. And here, this may be the highest CAM. Okay, so it is 512 CAM. Okay, but when it comes to here, it will be about 64 CAM likewise. Okay, but after 60 dBm, the modulation scheme will be shift to PSK, actually. PSK level. Okay, 16 PSK, QPSK. Okay, so very low SNR environment, we can use PSK. Okay, the signal is automatically shifted to PSK. Okay, so that means that the bit error performance of okay, the bit error performance of CAM is greater than the PSK. Okay, okay. So here I think you can find the D1 already find. Okay, that is 2 root T. D2 already find. Someone send me that it is. So this is 2 root T. Okay, 2 root T. Someone send me that this D2 is 0.2 root T something. 0.2 root T something. Okay, I don't know. So you can calculate this. Okay, you can calculate this using a calculator. Okay. Okay. So we will go to the next one. Okay. For the same average transmitted power here. So same average transmitted power and noise level, comment on the error probabilities in 16 CAM and 16 PSK. Okay, so what you can tell about this? Okay, so you can see that it is the same transmitted power and same noise level. That means the signal power is same, noise power is same. That means SNR is same. Okay, so we are talking about in the same SNR value, in the same SNR value. Okay. So in the same SNR value, okay, which one have the so we have to comment on error probabilities, no? So we have to say that this one has higher error probability than this one. That is the answer here. Okay, and we have to justify it. Okay, so we have to find. Okay, so what do you think? Which one have the higher error probability? This one or this one? Tell me. What do you think? Just tell me. So you can also find that the distance between 2 points will be yes, higher error probability should be in PSK. Yes. So how we can calculate it actually? How we can justify it? So you can see that between two adjacent point in CAM, it is 2 root T. Okay. So so there is some distance. Okay. What happens if this distance is very low? If this distance is very high, what happens? If this distance is high, what is the advantage? If the two adjacent point of a constellation diagram have a large distance, so what is the advantage or disadvantage here? So you can see that if it has very considerable distance, if 2 points has very considerable distance, okay, okay. So if you add some noise value to here and noise value to here, okay, noise value to here, okay, okay, what happened? Okay, so sometime if this distance is too small, so if you add some noise value here, this point, there is a higher probability that this point is shifted to this range. No, is that clear? If you have 2 points in a consolation diagram, okay, so you have 2 points here, 1 point here and 1 point here. So your decision region will be like this, okay, the middle point, okay, middle line between these 2 points. So this is your decision boundary, okay. Now so when you transmit the signal, some noise will be added to this signal, okay. And it can be anywhere here, okay, anywhere here, okay. So you can see that if this distance is very small, sometime when if some very small noise power added, sometime this point can be shifted to this region, no, if this distance is very low, okay. So this point, the point in this area can be shifted to this area, okay. So it make a error, no, it make a error. So you can say that if the distance is very low, error probability is high. Error probability is high if the distance is low, okay. If the distance between two cancellation point, distance between, I will write here, distance between, okay, two consolation point, okay, consolation point, distance between two consolation point is higher, what is has the bit error probability, bit error probability will be low, okay. But what happen if the distance is lower? There is high probability to shift this region point to this region, okay. So the distance between two consolation point are very very low, okay, very low, okay, very low. What happened? The error probability will be very high, okay. So here error probability will be very low, okay. So are you okay with this? Can you understand? Okay, I will repeat it again. If you have two symbol, okay, if you have two symbol, okay, so if you have the higher distance between two signal, okay, so this distance is higher, okay, you will be having very low error probability, okay. But if this distance is very low, you will be having very higher probability, okay. So in this question you can see that the distance of the minimum distance of two adjacent point in CAM we take as D1 is greater than the adjacent distance of adjacent the distance of adjacent 2 point of PSK 16 PSK D2, okay. So definitely this will have lower error probability and this will have higher error probability, okay. So this is CAM will have lower error probability and this is PSK will have higher error probability, okay. Actually, you can estimate it numerically. Okay, I don't know. So now that is the expected answer. Okay, so you can say that the answer is because in 16 cam we have the higher distance between two adjacent points. The cam will have lower error probability, and because PSK has very small distance between 2 points compared with CAM, okay, PSK will have higher probability. Okay, so that is the answer, expected answer. Okay, but actually you can measure it numerically. Okay, you can measure it numerically. I just I just tell it to your knowledge. Okay. If you are doing it, if you are in industrial training or something, I think that knowledge may be important. If you go to the drive test, okay, so you can see this. Okay, so so let's say that you have one distance d2 and another distance d1, and say that this d2 d1 is greater than d2. Okay, so if you get the ratio between this d1 and d2, okay, and if you get the logarithmic value, the decibel value of this ratio, okay, of this ratio, the distance ratio, okay, so first you get the ratio. This is the highest distance and this will be the lower distance. Okay, so this is the higher distance. Okay, and if you get 10 log 10, okay, so you will get the dB value. Actually this will be plus dB value because this is higher. Okay, this is higher. Okay, so to have a same error probability, okay, to have a same error probability, let's say that it is x. Okay, x. Okay, so to have a same error probability, so this modulation scheme, let's say that this is M1, this is M2. Okay, modulation scheme. So M1 have, okay, some SNR value minus x. Okay, so it can have some error probability. Okay, error probability, and same error probability will have in M2 if it has SNR, if it has SNR value, okay, some dB value. So the SNR, say that is y. Okay, so for y SNR, for, so let's say it is 20 dB SNR. Okay, so 20 dB SNR in 20 dBm SNR value, if this M2 will have some error probability, P error probability, the same error probability will have in M1 in 20 minus x, okay, in this value, 20 minus x SNR value. So you can see that here the SNR is low. SNR low means the noise power is high. Okay, so this is the numerical estimation, but here it is not mentioned. Okay, so if you didn't understand this much, it is okay. Okay, but if you maybe in Google you can search this. Okay, okay, so okay, so we will try to do one question, at least another question. Okay, so I will do it. I will do it. But if you have any, now it is already time is fast. Okay, so if you have any work, you can leave the meeting. Okay, but I will continue. Okay, so if you anyone wish to be with me, you can be there. So if you have any problem, you can solve this at this point. Okay, so that is dependent on you. Okay, anyway, after 10 minutes I will start the next question. Okay, next question. So if you want, you can be with me, no issue. Okay, but